Today I'm going to do number 2 from the 13-3 classwork. Use the parent graph to graph g of x equals cube root of x minus 2. Step 1, parent graph f of x equals cube root of x. So you'll see I've already done step 1 here. This is the table that goes with our parent graph, and we also have the graph there on the graph already. So let's move on to step 2. To obtain the graph of g, well, let's compare g of x and f of x. If I look at g of x, the thing that's different is there's a minus 2 here. So what does that minus 2 do? It's subtracted from x inside the square root, so that tells us it's a horizontal translation. To obtain the graph of g, horizontally translate f of x right 2 units. So that means I'm going to take my parent graph, I'm going to shift each key point to the right 2 units. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And that's going to give me a new point here, 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 and here. So you'll notice these points are laid out similarly to the parent, but it's just moved slightly to the right. So there is our g of x graph. So what happens when I move a graph to the right too? What changes? Well, if I'm moving things left and right, it's only going to change the x's. It doesn't go up or down, so the y values are going to stay exactly the same as the parent. So I'm just going to copy those down. But the x values, if we're moving to the right 2, we're going to add 2. So negative 8 plus 2 is negative 6. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 8 plus 2 is 10. And you should hopefully notice that these 5 points in the table match the points that we have on our graph. So we have our graph of g of x. What is the domain and range of both graphs? And notice that it does say both graphs. It's because the domain and range are the same thing. So if I'm trying to find the domain, I'm talking about how far does it go to the left and to the right. So I can see that the graph keeps going on and on to the left and the right. So that means my domain goes from negative infinity to infinity. And I can write it like so in inequality and interval notation. When we're talking about range, we're talking about y instead. So it is kind of steadily going further and further up, and it is also kind of steadily going further and further down. So the y values go from also negative infinity to infinity, like so. And there we go. There's number 2 from our 13-3 classwork.